We're going to do the same problem, but we're going to revolve around x equals -2. Same problem, but x equals -2. X equals -2 is over here, correct?
Yeah.
Now once again, you see I have that gap? So when I revolve, I better have that same gap. We're going to have a big old empty bowl here. But you got to have that same gap. You cannot draw it next to that line, x equals -2. Even if you do the problem right, I will mark that wrong because that is a big issue. Big issue. What's that?
There's going to be a hole.
Yeah, it is. Yeah, it's like a donut kind of thing going on here. Okay, so we have outside, inside again.
Should you put it in terms of x first? In terms of y first?
I will. Yeah.
Okay.
I will as I'm doing this. Yep. Okay, so pi, my radius. Now here's my original, correct? Always use your original. That, from the axis to the function, is the function. But I've got an extra 2. So once again, I have 2 plus the function. But be careful. That was y equals x squared, which is really 2 plus square root of y. Let's go ahead and multiply that. So I'm going to actually end up with 4 plus 4 square root of y plus y. Everyone agree with that? Once again, you're going to do the same thing for the inside, but here's y. You're going to go 2 plus that inside, which is that line. That pi 2 plus, and what was the line? Y equals 4x. So x equals 1/4 y. Oops, and I wrote 1 more. Okay, 2 plus 1/4 y, and I cannot write 1/4 today to save my life. So I end up with 4 plus y plus 1/16 y squared. So when I set up my integral, the outside minus, we're going to distribute that, minus y. Now when I look at my bounds, I better be looking on the y-axis here. So I don't go from 0. Once again, we said they met when x equaled, down here. Right, but where do I have to work for that? Did I not write it down? It's not written it down. Oh, right over here, yeah, x equals 4. Now if you know x equals 4, just plug it into either function, right? X is 4, y is actually 16. Okay, so 4 is canceled. Ooh, y is canceled. That's nice. So I really have pi, the integral 0 to 16. We go ahead and write 4 to the 1/2 minus 1/16 y squared dy. So my antiderivative is what?
8/3 y to 3/2.
Does everyone agree with that?
Yeah.
Minus, what will I get here?
Whatever, 48.
Y cubed. Okay. Yeah. Well, let's do this. Remember what that means? That means 16 cube root, right? Or cube, which means 16, which is 16 times 4, which is 64.
Yeah.
But but times 8/3, that will give me 512 over 3. Once again, it's basic math, and if it takes you long, that's okay. Plug in 16. Well, 16 to the third. What is 16 to the third?
1,021.
Is it?
I think so.
No, it's not.
Well, 16 times 16 is 256.
Times another 16. So I see 16 times 16, you said was 256? Is that what you said? Times another 16.
Yeah.
36, carry the 3.
4,096.
And they're talking like it is math. 33, 12, 15, 0, 6, 5, 2, 6, 9, 0, 4,096.
Yeah.
Over 48, which does reduce, by the way. And let's actually do that now. Yeah. Let's see. Oh, wait. I wonder if,
Divide by 16.
I wonder if 48 is Ooh, it's too loud.
Get the clock.
Okay, what does that reduce to?
256 over
What?
256 over 3.
Does everyone agree with that, or should I just trust Caleb?
That's
usually
not a
also-
good idea, but
256 over 3?
you can do it.
So when I subtract, what will I get?
256 over 3.
What?
256 over 3.
256 over 3? Does that reduce?
No.
No. Because you know 3 won't go into that because you can add the digits, correct?
Right. Sure.
Okay. These are tough problems because you have to decide whether to add or subtract the number, and it's just going to depend on your picture. And a lot of these people do not do well on these problems. But be careful. You try and we're done.